How sound is produced. Sound is a form of energy. When you rang the bell, pluck the strings of the guitar, and tap the drum, you heard different sounds. You observe that objects move back and forth when they make a sound. This movement is called vibration. You hear sound when things vibrate. Without vibration, there will be no sound. Loudness. Many things make sounds. Some sounds are soft, while others are loud. When you struck the objects lightly, they produced soft sounds. When you struck them hard, loud sounds were produced. Did you notice that the sound was louder when you exerted more force? The loudness or softness of a sound is called volume. The harder you tap the drum, the more it will vibrate. The more an object vibrates, the louder the sound will be. The greater the energy used in producing sound, the louder is the sound produced. Look at the picture of the two drums. If you play with them, which one will produce a louder sound? Why? The loudness of sound also depends on the size of the vibrating object. The large drum produces a louder sound than the small drum. Why is this so? A large object causes more air to vibrate than a small one. When more air vibrates, a louder sound is produced. Pitch. Pitch describes how high or low a sound is. Objects that vibrate slowly produce sounds with a low pitch. Look at the picture of the two guitars. If you strum the guitar with short strings, what kind of pitch will it produce? If you strum the guitar with long strings, what kind of pitch will it produce? Compare the pitch produced by the two guitars. Which one produces a high pitch? The one with short strings or the one with long strings? Pitch is determined by the length of the vibrating object. Short strings vibrate more quickly than long strings. The shorter the vibrating object, the higher the pitch is. The longer the vibrating object, the lower the pitch is. Uses of sounds. Here are some uses of sound in our daily activities. Sound makes us aware of what is happening around us, like the emergency sound of an ambulance siren and fire truck horn. The sound of music and human laughter can inspire people to do something for others. Ultrasound used in the medical field sends sound waves into a person's body to provide digital images of what is inside for disease diagnosis or to check the condition of the fetus in pregnant women. When is sound considered noise? An unpleasant or annoying sound is called noise. Noise is sometimes considered a pollutant. Excessive noise is not good for us. People exposed to loud noise for a long period of time may suffer loss of hearing. Which of the following do you think will create noise? How sounds travel. Sounds travel in the form of waves. As one speaks, the sound waves travel through the air. Sound waves spread out in all directions. They are strongest near the source and get weaker as they move away from it. Most of the sounds that we hear travel through the air. Can sounds also travel through solids and liquids? Look at picture A. The girl is listening to a ticking clock. She can hear the sound of the clock. On picture B, she places her ear on the wooden wall of a room. She can hear her sister talking with someone. Sound waves travel through the wood. Wood is a solid material. Sound can also travel through liquids. You can hear somebody calling you when you are underwater. However, sounds travel at different speeds in different materials. Sound travels fast through solids because the particles of solids are very close to each other. Sound also travels through liquids like water. However, sound travels slower through liquids than through solids. This is because the particles in liquids are far apart from each other. Sound travels through air too. It travels the slowest through air because the particles in air are farther apart from each other than the particles in liquids. Sounds cannot travel in places where there is no air. Reflection of sound. Let us have this activity. Try shouting your name in a large empty room. What happens to the sound that you hear? Can you describe what you hear? Do you hear the sound of your voice even after you have stopped shouting your name? Why? Sound waves bounce off from different surfaces when you shout in a large empty space. The sound is reflected back or repeated. A repeated sound is called an echo. You can hear an echo when sound is reflected back to its source after striking a hard surface. Look at the picture. Do you know why theaters are lined with draperies? This is because the draperies can absorb most sounds, so only very little sound is reflected. Sounds may be absorbed or reflected when they strike an object. Protecting oneself from noise pollution. Always speak in a moderate voice anywhere you are. This means that the voice should not be too loud or too soft. Loud sounds such as the noise of the firecracker or the sound of a jet can damage your ears. Cover your ears when you hear very loud sounds. Avoid places where loud sounds are usually heard like construction sites and beside large speakers in concerts. Make sure that the sound coming from television sets, radios, and portable media players is not too loud. Constant exposure to noise can cause fatigue, headache, irritation, stress, and tension. In some offices or classrooms, noise absorbers are placed in the ceiling or walls to prevent sound from bouncing back too much. Heat and electricity. Heat is a form of energy. It is the result of the continuous motion of small particles that compose all matter. When a material is heated, these tiny particles, called molecules, vibrate faster. If the molecules absorb more heat energy, they will vibrate faster. As a result, the temperature will rise. Electricity is one of the sources of heat. Electricity works only when an electric current flows through a closed or complete circuit. In this lesson, you will start to understand electricity and its uses in our daily life, as well as its risks when not properly handled. Heat. Importance and uses of heat energy. Heat is a form of energy. It is very important in our daily lives. We need heat energy in many different ways: to cook our food, to dry our clothes, to boil water, to make the electric bulb function, and to make the air conditioner produce cool air. The heat from the burning fuels in engines makes cars, ships, and airplanes run. In factories, Heat is used to process food, iron, glass, and many other products. Heat also plays an important role in nature and the environment. For instance, the occurrence of seasons, rain, and wind are the results of heat energy changes in nature. Plants and animals also need heat to survive. Sources of heat. The sun. It is our most important source of heat. It produces heat by nuclear reaction. If the sun dies, the earth will become cold and lifeless. A tiny fraction of the solar heat that reaches the earth keeps us alive. The sun's heat is absorbed by the seas, the ground, the plants, and the atmosphere, the earth. The earth itself contains much heat deep inside. We observe some of this heat when a volcano erupts. We also have hot springs that shoot forth boiling water that has been heated by hot rocks within the earth. People have been using the earth's geothermal heat to generate electricity since a long time ago. Burning fuels. Burning fuels can produce heat. A substance that combines with oxygen rapidly produces heat fast enough to cause a flame. When coal, wood, natural gas, or any other fuel burns, substances in the fuel combine with oxygen in the air to form heat in various compounds. This reaction is known as combustion. Combustion produces heat and fire. Another example of combustion is the burning of gasoline in automobile engines. The process produces heat that causes the gases in the engine to expand and move parts that make the engine work. Electricity and its uses. Electricity helps us to read at night or use the computer. It also enables us to watch television and use other appliances. In our home, most of our appliances work because of electricity. If you notice, the electric cord connected to any electrical device has metal wires covered with rubber or thick plastic. This is because metal wires are good conductors of electricity, while the rubber or thick plastic, which covers the wires, is a good insulator. Conductors are materials that allow electricity to pass through, while insulators are materials that do not allow electricity to pass through them. Copper wires are electrical wires with insulators to prevent anyone from getting electrocuted. Before you can use any electric device, you turn on the switch. You turn the switch off when you do not need to use the device or appliance. Electric current. An electric current flows only when it can follow a closed path called a closed circuit. The circuit in the picture has three parts. First, something must push electrons through the path. The battery pushes the electrons. Second, an object in the circuit must allow the current to flow through it. The bulb lights up when current passes through it. Third, wires must connect the parts of the circuit. A wire connects the bulb back to the battery. Proper use of heat and electricity. Heat and electricity are very useful to us, but they can also be dangerous. They may cause fires and even deaths. Measures should be taken in using them at home to avoid accidents, injuries, loss of properties, and death. Here are some safety measures. 1. If you see lighted candles and lamps which are unattended or not used, put out the flame. 2. Matches and candles must be kept in places out of children's reach. 3. Check if all the electric cords are properly insulated. 4. Unplug electrically operated appliances like the stove and flat iron after each use. 5. Do not plug electrical appliances into an outlet when your hands are wet. Characteristics of living things and non-living things. Living and non-living things are all around us. In order to distinguish living things from non-living things, scientists listed 7 characteristics which all living things have. 1. Nutrition or food. All living things take food from their environment to get energy to grow and stay healthy. Substances that a living thing can use for energy and for growth and repair are called nutrients. Green plants, which are living organisms, can produce their own food. Animals, which cannot make their own food, must obtain them from the environment. 2. Movement. Movement refers to actions done by organisms. All living things move. Plants move as they grow and develop. Animals can move from one place to another by walking, flying, or swimming. 3. Respiration. Respiration is the process in which air is drawn into the body and waste gases are eliminated. All living things exchange gases with their environment. Animals take in oxygen and breathe out carbon dioxide. Plants need carbon dioxide to be able to produce their own food. 4. Excretion. All living things produce substances that they cannot use and that may be harmful if allowed to stay in the body. The removal of these wastes is called excretion. In humans, these wastes include carbon dioxide, excess salt and water, and unused waste food or feces. 5. Growth. Growth is the process wherein living things increase in size. Living things grow. When living things are fed, they gain energy. Some of this energy is used for growth. 6. Sensitivity. Living things react to changes around them. They react to touch, light, heat, cold, and sound. For example, if you touch the leaflets of the macahiya plant, you will notice that the plant reacts by closing. Another example is the movement of leaves to the direction of light. 7. Reproduction. Reproduction is the process by which living things produce new organisms of their own kind. All living things produce offspring. Humans make babies, cats produce kittens, and birds lay eggs. Plants also reproduce. Many make seeds that can germinate and grow. Characteristics of non-living things. The most important characteristic of non-living things is the absence of cells, which are the basic building blocks of life. All living organisms must have at least one cell to be alive. Because of the absence of cells, non-living things cannot perform activities. Non-living things cannot move by themselves. They have no methods of movement. They remain immobile or motionless. Since no activities are possible for non-living things do not obtain energy from their environment to sustain themselves. Non-living things cannot grow, so they do not need food, water, air, and shelter to stay alive. Non-living things cannot multiply, they cannot reproduce, and they do not die. Can you now give examples of living things and non-living things? In what way are living and non-living things similar? In what way are they different? Right food to eat. Go, grow, and glow foods. Your body is like a machine. Machines need fuel to make them work. Your body needs fuel too. Your body needs food that contains vitamins and minerals. The right kind of food helps your body do different activities every day. Carbohydrates and fats. You need food for energy. Energy keeps your muscles working. Carbohydrates and fats are energy foods. They are kinds of go food. Your body needs go foods to help you grow. Go food serves as fuel for the body because they give you energy. Foods rich in carbohydrates are bread, rice, noodles, potatoes, and corn. When you eat food rich in carbohydrates, you are giving your body a lot of energy. Bananas and potatoes are high energy-giving foods. Fatty foods include butter, margarine, and vegetable oil. When you eat too much fatty food, you store extra fats in your body. Too much fat is not good for the body because it can cause heart diseases. Protein. Proteins are food materials that build and repair body tissues. Foods rich in proteins include meat, fish, milk, beans, and eggs. They make your muscles strong. Affordable foods rich in protein are eggs, nuts and seeds, peas, and beans. These are grow foods which are necessary for growing children. Vitamins. Vitamins help your body work well. Some vitamins are good for the eyes. Some are good for the teeth and bones. Others are good for the skin and for the healing of wounds. Foods that are rich in vitamins are called glow foods. These include fresh fruits and vegetables. Minerals. Minerals are also needed by the body. Milk, eggs, liver, and some green vegetables are rich in minerals. Calcium is a mineral. It helps in building stronger bones and teeth. Iron is also a mineral. It helps the blood carry oxygen to different parts of the body. Iodine is another mineral. It is good for the thyroid gland. Selenium from onions and garlic is good for fighting diseases and infections. Good eating habits. A habit is something you do regularly. A good eating habit helps make your body strong and healthy. Growing children should practice good eating habits that will help them grow strong and healthy. Eat a balanced diet. A balanced diet is a meal that contains food from all of the basic food groups. You also need to drink plenty of water and fruit juice. Eat 3 meals a day. Eat breakfast, lunch, and dinner every day. Eat light snacks in between meals so that you will not lose appetite for the next meal. Do not skip meals even when you are in a hurry to do or finish an activity. Skipping meals can make you very hungry, and this is not good for the body. Avoid eating junk food. These are not good for your body. They can make you sick. Foods that are not safe to eat. What are the kinds of food that are not safe to eat? Why are they not safe to eat? What might happen if you eat food that is not safe and is exposed to germs? The kinds of food that are not safe to eat and drink are expired and dirty food. They are the sources of foodborne diseases like diarrhea, allergies, vomiting, and dizziness. Foodborne diseases are infectious. They can cause irritations of the gastrointestinal tract. Such infections are caused by harmful bacteria, parasites, or chemicals contained in the food. Foodborne illnesses can be prevented by checking the expiration period of the food products, by properly cooking and handling food, and by practicing healthful habits. Good, healthful habits. Personal hygiene. We need to practice good, healthful habits to help prevent diseases. These are ways to have good, healthful habits. Take a bath regularly. Shampoo your hair properly. Wash your hands with soap and water often before and after eating. Wash your hands each time you use a toilet and after you blow your nose. Dry your hands thoroughly after washing them. Use sanitizers to kill germs that cause illnesses. Sanitizers can be used if soap and water are not available. Brush your teeth after every meal and floss your teeth at least 2 times a day. Wear clean clothes and shoes always. Use clean tissues or handkerchief to cover the mouth and nose when coughing or sneezing. Throw your used tissues in a trash can. Do not share combs, toothbrushes, hats, or other personal belongings with other children. Visit your doctor and dentist regularly. Always keep your body and surroundings clean to prevent parasitic worm infestations like hookworms and pinworms, which can enter your body. This will also prevent pediculosis, which is an infestation of body lice on your scalp. If you will not practice good healthful habits and personal hygiene, germs will enter your body. Germs are organisms that can cause diseases or illnesses. Illnesses can affect one's growth and development. Force and motion. Motion is another word for movement. Objects cannot move by themselves. They need force to be able to move. A push or a pull that makes things move is called force. The wind causes the branches and leaves to move. Running water causes the stones and rocks to move. Wind and running water cause motion. They are forces that make objects change position. What makes things move? You see people moving around. You also see things being pushed or pulled to move them. Force is needed to make things move. Energy provides the force that makes things move. There are different forces which can make things move. Wind can cause kites to fly. Running water can move logs down from a mountain. Electricity. The electric fan is moved by electricity. Electricity is a source of force. It can move electrical objects, appliances, and machines. Electricity is a form of energy that can make the blades of an electric fan move. Electricity from a battery can make a toy car run. It can make toy trains and dolls move. Electricity can make things move. Magnetism. A magnet can move some objects. It can push, pull, or attract some objects. A magnet is a piece of metal that comes in different shapes and sizes. A magnet has two ends, the North Pole and the South Pole. The North Pole of the magnet usually has an N on it. The South Pole of the magnet usually has an S on it. The force of a magnet is much stronger at its poles than at its middle. The two poles are the strongest parts of a magnet. When the North Pole of one magnet is placed near the South Pole of another magnet, they attract each other. When the North Poles or South Poles of two magnets are placed near each other, they repel or push away from each other. What kind of objects or materials can a magnet attract? Let us find out. Magnets exert a force called magnetic force. Magnetic force pulled the thumbtacks, iron nails, and paper clips toward the magnet. Objects made of iron and steel can be moved by a magnet. They are called magnetic materials. However, not all objects can be moved by a magnet. Objects that cannot be moved by a magnet are called non-magnetic materials. There are three kinds of magnets: permanent magnets, temporary magnets, and electromagnets. Permanent magnets always attract magnetic objects. Temporary magnets are objects that become magnetic when they are near permanent magnets. Electromagnets are objects that can become magnetic in the presence of electricity. Earth's gravitational pull. Everything on Earth falls to the ground. What force pulls things toward the ground? Let us have an activity. Throw a small stone up in the air. What happened after? Throw a sheet of paper up in the air. What happened after? Observe the dry leaves of the trees falling to the ground. The Earth's pull makes the stone, paper, and leaves of trees fall to the ground. The Earth's pull is called gravity. It is a downward force exerted by the Earth. It is a natural force that pulls things toward the center of the Earth. The Earth acts like a magnet that pulls objects to itself. This pull of the Earth on objects is known as the force of gravity. Without gravity, we cannot live on Earth. Everything will float. Nothing will pull us down to the ground. Being safe with moving objects. If you are using electricity to make an object move, use dry hands to plug the electric cord. Using wet hands may give you a shock or an electric jolt. Wait until the object stops moving before holding it. Do not try to handle the object while it is still in motion. Stay away from the path of moving objects. Do not expose your hands, feet, or any part of your body to the moving objects. Types of clouds. The clouds in the sky have different types. Cirrus clouds. Cirrus clouds look like white feathers in the sky. They are the highest clouds in the sky. They also indicate fine weather. Cumulus clouds. Cumulus clouds are big, thick, and puffy. They look like white cotton candies. They also indicate fair weather. Stratus clouds. Stratus clouds look like layers of fog in the sky. These layers of clouds cover almost the entire sky. They are low clouds. They are more known for drizzle. Nimbus clouds. Nimbus clouds make the sky dark. They give a clue that it would rain. Nimbus clouds are also called rain clouds. Sky condition. Just by looking at the sky, some people can already tell what the weather would be for the day. When the sky is clear, this means that the weather is fair. Sometimes the clouds cover more than half of the sky. It is said to be cloudy. The weather is still fair if the clouds are white. When the sky is covered or overcast with dark clouds, the weather is rainy. Moving air. Air may be still or moving. When it is still or does not move, the air is calm. Moving air is called wind. When the wind is moving slowly and gently, it is called breeze. A slow and gentle breeze may move clothes hanging on a clothesline and lifts very gently. This indicates fair weather. Classification of animals. Scientists have classified animals into two big groups. They are invertebrates and vertebrates. Animals without backbones are called invertebrates. Animals with backbones are called vertebrates. Their backbone is described as vertebral or spinal. This bone houses the spinal cord. They can be found just about everywhere, in oceans, rivers, forests, mountains, and deserts. The 5 classes of vertebrates. There are 5 groups of vertebrates: the fish, the amphibians, the reptiles, the birds or fowl, and the mammals. The fish are the simplest of the vertebrates, while the mammals are the most complex. Fish. They are the largest group of vertebrates. They come in many sizes and shapes. The body parts of fish are suited for life in water. The bodies of most fish are covered with scales. They reproduce by laying eggs. Fish are able to breathe in water because they have gills. Gills enable the fish to take in oxygen from water, which is important for their survival. Fish are cold-blooded animals. This means that their body temperature adapts to the temperature of their habitat. Amphibians. Amphibians can live on land and in water. As they grow, their gills disappear and replaced by lungs. They take in oxygen in 2 ways, either through the lungs or through the skin. Amphibians are cold-blooded animals. Frogs, toads, and salamanders are the most common amphibians. Amphibians have different body covering or skin. Frogs have smooth and moist skin. Toads have bumpy and dry skin. Salamanders have thin and moist skin. These amphibians live in creeks, ponds, and streams. Reptiles. There are 4 kinds of reptiles. They are the crocodiles and alligators, turtles and tortoises, lizards, and snakes. The body of a reptile is covered with scales and hard bony plates. Its skin is dry and cool. Like fish and amphibians, reptiles are cold-blooded animals. All reptiles have lungs. Many of them live on land, while some live in water. Reptiles can move at various speeds. They lay their eggs on land. They live in hot, dry deserts and in warm, wet tropical rainforests. Birds or fowl. Birds are warm-blooded animals. Their body temperature does not change in any kind of weather. Their bodies are covered with feathers, which keep them warm. They reproduce by laying eggs. All birds have a pair of wings, but some cannot fly. They also have 2 legs for walking. Some common birds are chicken, ostrich, duck, and pigeon. Mammals. Mammals are the most highly developed among the groups of vertebrates. Their bodies are covered with hair or fur. They have mammary glands that secrete milk, which they use to feed their young. They are warm-blooded animals. Mammals may be grouped into 3 groups according to the way in which individuals develop the fertilized eggs. 1. Placentals. They are mammals wherein the embryo receives nutrients and oxygen from the mother's body through an organ called placenta. Examples are dogs, cats, and elephants. 2. Marsupials. They have pouches where their young complete their development. Examples are kangaroo and koala. 3. Monotremes. They are egg-laying mammals. Examples are duck-billed platypus and short-billed echidna. What are invertebrates? Invertebrates are animals without backbones. You may have seen many animals without backbones. Most of these animals can take care of themselves as soon as they are hatched from eggs. Invertebrates live and grow in different ways. Insects are the largest group of invertebrates. They are animals with 6 legs. They use their legs in moving around and capturing and holding their food. Most of them have 1 or 2 pairs of wings, which they use in moving about from one place to another. Insects live in almost all parts of the world. Many insects are found on land, while some in water. Some kinds of butterflies and dragonflies live at the top of the mountains. There are those that live on the bodies of other animals. Still, others make their homes within the bodies of plants. Effects of human activities to Earth's land and water. Erosion of soil. People cut down trees in the forest for their needs. Most often, people do not plant new trees. Too much cutting down of trees results to forest denudation. When people do not plant new trees, floods can occur when heavy rains come. This is because very few trees are left to hold water underground. Floods can wash away the soil. This is called soil erosion. Soil erosion removes the most important layer of the soil called topsoil. Landslides can also happen since few trees are left to hold the soil together. Landslides can harm people living at the base of the mountain and on its slopes. Soil pollution. Many human activities pollute the soil. Pollution harms the productivity of the soil. People throw garbage and wastes improperly. Garbage destroys the fertility of the topsoil. Plants cannot grow on soil covered with garbage. Overuse of fertilizers and pesticides by farmers to increase the harvests destroys the quality of soil. Rice fields and other agricultural lands are converted into residential and commercial areas. Some people convert farmlands into livestock and poultry farms to meet the needs of multinational companies. This practice can make farmlands exposed to agents of soil erosion. Water pollution. Our water is becoming dirty. Dirty water is polluted water. Why is water dirty now? Let us find out. Seas, rivers, and lakes are homes of many fishes. These bodies of water become dirty when people throw garbage and human waste into them. Some people wash clothes in rivers and lakes. They use detergents and bleaching materials that contain chemicals that pollute rivers. When water becomes polluted, fish and water plants will die. People cannot use the water anymore. Polluted water can also cause diseases. What are the proper ways of disposing garbage? Some people bury their garbage under the ground. Others put their garbage in front of their houses for garbage collection. Air pollution. Humans and animals need air in order to live. They need clean air to breathe. If they breathe polluted air, they will get diseases that may lead to death. Polluted air is dirty air. The piles of garbage lying around the streets make the air dirty. Dirty surroundings pollute the air. The odor from dirty canals makes the surrounding air unsafe to breathe too. The black smoke coming from factories pollute the surrounding air. The black smoke contains substances that are poisonous. They can make you sick. The smoke coming from the engines of cars, jeepneys, trucks, and buses pollute the air too. It makes the air harmful and unsafe to breathe. The smoke coming from cigarettes also makes the surrounding air polluted. Nowadays, air pollution is a serious problem, especially in cities. You have to be alert and help prevent air pollution. What can result from pollution? Waterborne diseases. Waterborne diseases spread through contaminated water. Some examples of waterborne diseases are the following: cholera, dysentery, typhoid fever, and diarrhea. Infection can result not only from drinking but also from swimming in the dirty water. Bacteria can enter the body through broken skin. Always seek medical advice when you are infected by waterborne diseases. Airborne diseases. These diseases are caused by bacteria which get discharged through coughing, sneezing, or through close personal contact. Some examples of these diseases are the common cold and cough, throat infection, influenza, chickenpox, and tuberculosis. The risk of getting infected with airborne diseases is high. However, observing simple precautionary methods can prevent the spread of infection. For example, avoid contact with people with the disease, or wear a mask that can provide some protection. Covering the mouth while sneezing or coughing can cut down the spreading of infected droplets. Soil-borne diseases. Soil-borne diseases are diseases that are caused by fungal infection which survive in the soil surface. Plant parts that are affected show stunting, wilting, and eventually dying. Care and concern for the earth. We need to protect the earth. It is our home. It has air, water, and land where living things live. We must keep them clean. Here are some ways to care for the earth. Plant more trees. They help prevent the soil from being washed away. They also make the surrounding air fresh and clean. Dispose of your garbage properly. Scattering it on the ground and throwing them into any water form will contribute to air and water pollution. Do not throw trash into bodies of water. Your garbage should be segregated as biodegradable and non-biodegradable. Biodegradable is the garbage that decays, like chicken bones, some clothes, and fruit peelings. And non-biodegradable are garbage that does not decay, like plastic, glasses, and synthetic rubbers. Biodegradable garbage can be put in compost pits to make natural fertilizer. Non-biodegradable garbage may be reused or recycled. Avoid burning trees. This activity destroys the fertility of the soil. Do not burn solid wastes like paper, plastics, and other materials. The smoke from burning materials pollutes the air and destroys our atmosphere. Avoid excessive cutting down of trees. Forest denudation causes flooding and soil erosions. Save water and electricity. Closing the faucet well and turning off the lights when not in use can help conserve water and electricity. Branches of science and scientists. What is science? Science is learning new things. Would you believe that the repositioning of the teeth makes it possible to rejuvenate facial appearance by reshaping the jaw, neck, and lips? That is what today's orthodontics is. Inventing new things. Greater things have happened since the invention of the television. Now, satellites send television signals around the world. These satellites allow people to see live broadcasts from all over the world. Exploring the unknown. In 1609, Galileo was the first person to study the moon through a telescope. Eventually, the Hubble telescope was launched into space. It has captured images of the solar system and other heavenly bodies. In your science class, you observe, you learn, and you discover new things through experiments by using different laboratory apparatuses. You work like young scientists. Scientists are experts in the study of different branches of science. You learn many things from their discoveries and inventions. Branches of science. Here are the different branches of science. Biology is the study of living things, including their structure, function, and growth. An expert in the field of biology is called a biologist. Botany is the study of plants, including the characteristics of plant parts, how plants make food, and how they reproduce. An expert in the field of botany is called a botanist. Zoology is the study of animals, including the structure, habits, and distribution of all animals. An expert in the field of zoology is called a zoologist. Chemistry is the science of the composition, structure, properties, and reaction of matter. An expert in the field of chemistry is called a chemist. Physics is the science of matter and energy and the interaction between them. An expert in the field of physics is called a physicist. Ecology is the study of how organisms interact with one another. An expert in ecology is called an ecologist. Geology is the study of Earth's rocks and features on land and the changes that the Earth is undergoing. An expert in geology is called a geologist. Meteorology is the study of weather and climate. An expert in the field of meteorology is called a meteorologist. Astronomy is the study of heavenly bodies. An expert in the field of astronomy is called an astronomer. Taxonomy is the science of classification of plants and animals. A scientist who studies taxonomy is called a taxonomist. The scientists. People who are experts in the field of science are called scientists. Here are some of the famous scientists and their works. Foreign scientists. Louis Pasteur was a French scientist who became famous for his work on fermentation and decay. His experiments supported the germ theory of disease, which showed how microorganisms such as bacteria and viruses can cause diseases. He is also credited for the practice of vaccination to prevent disease. Nicholas Copernicus was a monk from Poland. He went against the idea that the Earth was the center of the universe and all the stars and other planets revolve around it. Through his research, he made a Copernican model of the solar system and proposed that the sun is the center of the universe and all the planets revolve around it. Thomas Alva Edison was a very curious child. He loved to experiment. To earn money to support his experiments, he went to work at the age of 12, selling newspapers and candies on trains. At the age of 22, he already made many inventions. He worked day and night. One of his famous inventions was the phonograph, a device that makes and records sounds. In addition, he improved the electric light bulb and Alexander Graham Bell's telephone. Filipino scientists. Arturo Alcaraz. Arturo Alcaraz is considered the father of Philippine geothermal energy development. He is credited for making the Philippines the world's second largest producer of geothermal energy. For his contributions in geology, he won the Ramon Magsaysay Award in 1982. Rolando de la Cruz. Rolando de la Cruz was awarded Outstanding Technology Gregorio E. Zara Medal for his various herbal and antiviral products. From the extract of cashew nuts and other herbs, de la Cruz came up with healing creams for warts, moles, and fungi infection. His most popular products are the mole and the wart. His inventions won a class award from the Department of Science and Technology. Since then, he has won gold medals at Inventors Fair in many countries. Dr. Fe del Mundo was a Filipino pediatrician. She founded the first pediatric hospital in the Philippines. She was also known for the invention of the improved incubator and the jaundice relieving device. She dedicated her life to the cause of pediatric medicine in the Philippines. She was the first Filipino woman to be named as a National Scientist of the Philippines. Science laboratory tools. Study the different science laboratory tools and their uses. A microscope is an optical instrument that enlarges images of minute objects that cannot be seen by the unaided eye. A magnifying glass is an instrument used for observing tiny objects. Test tubes are used for heating small amounts of liquid. A test tube holder is a metallic device used to hold a test tube while being heated over a flame. A graduated cylinder is used for measuring the volume of liquids like water, oil, and other solutions. An alcohol lamp is used for heating materials. An evaporating dish is a porcelain dish used in evaporating chemical solutions. A beaker is a thin glass vessel used as container for fluids. It has graduation for the measurement of volume. A thermometer is used for measuring temperature. A funnel is a device used when pouring liquids or fine particles to a small-mouthed container to avoid spilling. Earthenware flask with stirrer on a hot plate heats the liquid with continuous stirring. Litmus paper is used in identifying if the liquid is an acid or base. Table beam balance is used in getting the mass of objects. A digital microscope provides a different feel and sight at proving the structures of a cell. Mortar and pestle are used in grinding materials such as leaves in a chromatography experiment. Telescope is used for looking at objects that are a great distance away. A test tube rock is used to hold multiple test tubes upright at the same time. They are especially useful for organizing test tubes when different solutions are being worked on or collected at once. A compound microscope. A very important device that is used in the science laboratory is the microscope. A device that gives an enlarged picture of tiny objects. Let us study the parts of a compound microscope as seen from the picture on the right. A compound microscope has an optical system, a mechanical system, and a light system. The lenses which make up the optical system of the compound microscope are usually two or more objective lenses of different magnifying powers. A low-power objective is used first to locate the region of the specimen to be examined. If further magnification is wanted, a high-power objective is then moved into position. The microscope usually has just one eyepiece or ocular. However, in some cases, the ocular or eyepiece may be removed and replaced by another of different power. Usually, you will find 3 or 4 objective lenses on a microscope. They almost always consist of 4x, 10x, 40x, and 100x powers. When coupled with a 10x most common eyepiece lens, you get total magnifications of 40x, 4x times 10x, and you can still increase the magnification to 100x, 400x, and 1000x just by combining two lenses. Meanwhile, the condenser lens is used to focus light onto the specimen. Condenser lenses are most useful at the highest powers, 400x and above. The mechanical system consists of the structural parts that hold the specimen in lenses and permit focusing of the image. The tube connects the eyepiece to the objective lenses, while the arm supports the tube and connects it to the base that is at the bottom of the microscope to provide support. The stage is the flat platform where you place your slides, and the stage clips hold them in place. The revolving nosepiece or turret is a part that holds 2 or more objective lenses and can be rotated to easily change power. The light system consists basically of illuminator or mirror and diaphragm or iris. An illuminator is a steady light source, 110 volts, used in place of a mirror. If your microscope has a mirror, it is used to reflect light from an external light source up through the bottom of the stage. The diaphragm or iris is a rotating disc under the stage. This diaphragm has different size holes and is used to vary the intensity and size of the cone of light that is projected upward into the slide. How to use a microscope. When using the microscope, remember the following. Make sure the microscope is steady with its base sitting on a flat, stable surface. Notice the eyepiece at the top. This eyepiece fits into the tube of the microscope. Adjust the mirror near the base of the microscope so that the right amount of light is sent up to the tube. Put the microscope slide on the stage with the material to be viewed over the hole in the stage. Use the stage clips to hold the slide in place. There are 2 or 3 objective lenses attached to the nosepiece at the base of the tube. One is low power, one is medium power, and the others are medium or high power. Always use a low power objective first. Turn the nosepiece until the lens clicks into place. Look through the eyepiece and turn the coarse adjustment knob to move the lowest power objective lens down close to the stage. Look through the eyepiece and turn the coarse adjustment knob until your specimen is in focus. Turn the fine adjustment knob to make the focus clearer if needed. Change the objective lens from low to medium or high. Be sure that the objective lenses do not hit the stage when you rotate them into place. This could scratch the fragile lenses or break the slide.